Hi class, Bob Greavy here. In this video we're going to talk a little bit about forecasting, chapter 15's topic. What I've done is I've built a spreadsheet, real simple stuff. I've got a column here that represents a particular week of the year and the demand that we experienced during that week. So you're looking at historical data. This has all already happened. And what we can do now is we can look back and we can look at demand over the last year. This goes all the way through 52 weeks. If I scroll down here, I can look back through all of that data and see if I can infer some things, see what's going on there. And we're going to talk about what we do with this type of data. One thing we can do is we can make a naive forecast from one week to the next, which simply says the next week's forecast equals what really happened this week. It's called a naive forecast for a reason. It may be naive to think that. Another thing we can do is we can do something called a moving average, in which we incorporate maybe not just the last period's data, but several periods of data in an effort to smooth things out. And I'll explain what that means here shortly. There's other fancier things we can do. We can do exponential smoothing, and we can actually do a regression analysis and find a line that best fits the data. So those are the things we're going to talk about right quick. So what I want to talk about first is a naive forecast, because it's kind of the simple thing, the simplest thing we can do. And let's pretend that all of this time has not yet happened, and I am sitting here at the end of week 1, and I am going to forecast for week 2, and I'm going to use a naive forecast. Well, my naive forecast would have been 44. In other words, the forecast for time period 2 would have been equal to the actual data from time period 1. And so the naive forecast for time period 3 would have been 48, and so on and so forth. Well, I can look at this quickly in a spreadsheet and ask myself, what would have happened if I had used the naive forecast? So I'm going to put a formula in here. It's going to be B4 in this particular cell, because what I'm doing is I'm looking at the previous actual demand as my forecast for a current period I'm looking at. Okay. Now what I'm going to do is I'm going to copy that formula downward, and I'll generate all of the naive forecasts that I would have used over the last year's sales. So we have demand. I should have started by explaining that. So typically, one thing we're very interested in forecasting is demand for our product. So this might be thousands of units sold in a year, or hundreds of units sold in a week rather. And now what I can do is I can ask myself, how would the naive forecast perform? How would it have performed if I had used the naive forecast? What would have happened? Well, we can calculate an error here. We'll call it the naive error, and that's the error that we would have experienced had we used the naive forecast. An error is simply the actual, what actually happened that week, minus what we forecasted to happen. So the error is actual minus the forecast. So we'll put a formula here so that we can copy it quickly. We know the error in week 2 was 4, because it actually had sales of 48 units. We had forecasted sales of 44. So we'll just put B3 minus C3, and there's my forecast error. I'm going to hit Control C and copy and paste this through all of the forecasts, the naive forecast. Okay. Now what happens when you use a naive forecast, which may not be a bad idea, but what tends to happen is we incorporate 2 things in that forecast. There's some actual wisdom, if you will. There's some actual real value to the data that exists from the previous week. The rest of that's going to be error. So you're also incorporating all the random variability from the week before. Just we may not want to incorporate all of that. So when you use the naive forecast, you get all of the noise, all of the random occurrences that caused last week's forecast. One thing you can do to combat that is called a moving average. And you may decide to take multiple weeks and average them. So let's do a 3-week moving average and see what that looks like. Okay, so I'm going to call this an MA3, moving average 3 weeks. And what I'm going to do is I'm going to take the first 3 periods of time and I'm going to average those. So the first 3 actual demands were 44, 48, and 44 again. And I'm going to use those first 3 time periods to forecast for time period 4. So that's going to look like this. We're going to say equals B2 plus B3 plus B4. And I'm going to divide that by 3 because it's a 3-period moving average. So the average from the first 3 periods of time was 45 1/3. I'm going to copy that down, and it's called a moving average because every time I copy that down, I'm going to pick up 1 period of time and I'm going to get rid of another. In this example, when I copy this down 1 row, let's do that. I'm going to pick up B5 and get rid of B2. So I'm only looking at the most recent 3 periods of time, and that's why it's called a moving average. So let me copy this formula all the way through, and we'll see how that performs. Okay, so here are my forecasts using what's called a 3-period moving average. Now what happens when you use multiple periods? There's nothing special about 3, by the way. It could have been a 5-period moving average or a 10-period or whatever you want. But what happens when you use multiple periods of time are these instances where the error or the forecast was a little bit high or canceled by those time periods where it was a little bit low. If you ever look at a map of the stock market's performance over time, it looks very jagged. You can picture that in your head. There's a lot of little bumps. And those little bumps you might call or attribute to just kind of a random or inherent variability in something like the stock market. Well, we don't want to incorporate the little bumps, either up or down, into our forecast. And what happens if you use multiple periods, the bumps where the forecast goes up, or where the actual data rather goes up, are offset by those time periods when the actual data goes down. And by averaging across time, those little bumps get canceled out. And we're left with, hopefully, what is happening at the core, or what is really happening in the data. So that's the purpose of a moving average. It's to cancel out some of that noise that occurs when we just do a naive forecast. Okay, so that's what we've done here. One thing we can do is we can measure the error. Let's call it the MA3 error. And we'll do that the same way. We'll just look at the actual, which was in cell B5, minus what we forecasted, E5. And now we can, oops, that should be a minus, not an equals. Okay. And now we can copy that formula down and look at the errors across the entire year. So what we're saying is, what if I had used that forecasting tool for the entire year? How would it have performed? Well, you don't necessarily want to look at 50-some errors. You need one number to kind of explain all of those errors. And what happens if you take a simple average of something that can be both positive and negative, you can get a number that looks very much like 0 and imply that your forecast is doing well when in fact it's not. So let's look at what happens if I just take a simple average of this error column here, which I think started with D3 to D53. If I do that, it looks like a very tiny number, less than 1. Similarly, if I do that over here, equals average D, or rather F5 through F53, I get an error that is perhaps less than it might be if we didn't have both negatives and positives canceling one another out. So this number is difficult to interpret. And what we tend to do in order to combat that issue is we either take the absolute value of errors so that the negatives don't have an opportunity to cancel out the positives, or we square the errors. Of course, if you square a negative number, it's positive. If you square a positive number, it's positive. So both of those take care of the issue of not having the issue of the negatives canceling the positives. So what we can do is we can calculate something called a mean squared error and a mean absolute deviation, or a mean absolute error. So let's look at the mean absolute error to begin with. So I'm going to calculate the mean absolute error. Let's do this for naive. And after that, I'll calculate the mean absolute error for the moving average, the 3-period moving average. Okay. So we have the error in let's see, cell or column D here. And what I want to do is I just want to take the absolute value of those errors. So I'll type equals absolute, or ABS, and then I will reference the cell the error is in, which is D3, and that'll give me the absolute value of the cell in that in D3 in that example. I can copy this down, okay, through all of the errors. And you'll notice this is nothing but the error reported in cell D, but now all the numbers are positive. If I take a simple average of this, let's see, it started in cell D3. If I say equals average D3 colon D53, then I get the exact same number. What have I done here? Oh, let's do that again. Equals average, not column D. Your professor had a goof there, but rather we want to look at column G, G3 colon G53. Okay, see the difference? When we look at the absolute error, it's significant relative to the average because the average had those negatives canceling those positive numbers. Okay, let's do the same thing with the moving average. And let's come down here. Let's take the absolute value of each of those moving average forecast errors. So that's column F. We'll copy those downward. And Control B. So now I have the absolute values of column F and column H. And all I need to do is copy this formula over. And now this 4.727891 is the absolute value of the moving average. So here's something kind of interesting. Very little difference in the naive forecast results and the moving 3-period moving average results. Okay, so what we've done, I'm running out of time for this video, so I want to just kind of summarize. What we've done now is we've looked at a naive forecast, a moving average forecast. We've discussed why you might use one or the other. And we've looked at it at the error term. We've also looked at something we do to the error term in order to make it more meaningful. In that example, we've taken the absolute value of that. And we'll pick up here in the next video.